Okay, so we are going to just do our acceleration notes. And if you notice, I have titled it Acceleration Notes.
Cameron Ritter and Taylor Ritter, please come to the office. Again, Cameron Ritter and Taylor Ritter.
Okay.
Please come to the office.
They are calling people to the office. All right, so for the acceleration notes, I'm going to start with the definition like we always do, and then we're going to talk about the equation and variables, and then we're going to go ahead and do some examples. So acceleration is the change in velocity over change in time. And another way I like to say it is the rate at which velocity changes. So rate is that word we use when we're talking about something that is happening usually with time. Okay, so speed is like a rate and velocity is a rate. Okay, so let's talk about the equation. And the main equation is acceleration equals delta v over delta t. So the triangle here is delta, and delta equals change in. So the change in velocity is telling us that a velocity has to change. So whether you speed up or slow down, or even change directions, you are changing your velocity. So we like to break that down to acceleration equals our final velocity minus our initial velocity divided by time. Now, we could even say final time minus initial time to get a change in time. But most of the time we start at 0 seconds. So we just go from 0 to 10 or 0 to 20. And so we use 20 seconds for our time. But sometimes you might start at 10 and end at 20. So it's the change in time. So you'd have to subtract 20 minus 10. So that doesn't happen very often, but you do have to know all the bells. I should have waited for all the bells. You do have to know that there's a change in time. So let's talk about our variables. And our variables are all of these letters that represent the different terms. So A, lowercase a, is acceleration. VF is our final velocity. VI is our initial velocity. And T equals time. And we're also going to talk about our standard units. Now remember, you can have all kinds of units, but our standard units, the ones that we use in most cases, is what we're going to talk about. So acceleration is going to be meters per second squared, which breaks down into a meters per second, if you remember that we talked about that. So instead of saying meters per second, we square these meters and we end up with a meters per second squared. So our velocity, our final velocity, is just a velocity unit, just like we've been doing. It's just meters per second. Our initial velocity, also a velocity unit, and our time we've done before as well, and it's going to be seconds. Okay, so one thing to note about acceleration is acceleration can be positive or negative. Wow, that was weird. Now my lights just went off. Okay, so direction matters. So remember, you can change direction. You can go right, or you can go up and be positive. You can go left or down and be negative, but you also can go in a circle at a constant velocity and change direction, and we still consider it changing acceleration or accelerating because you are changing velocity when you change direction, even if it's if the speed stays constant. Okay, so that's important to note. So let's go through our different equations. So we have our base equation, but we want to be able to find our other variables. So our final velocity equation is going to be final velocity, which is Vf, equals Vi, which is our initial velocity, plus A and T, which we're multiplying, acceleration multiplied by time. So when they're next to each other like that, that means we've got to multiply when they're next to each other. So A multiplied by T. So remember, orders of operation, PEMDAS, we don't have any parentheses, we don't have any exponents, but we do have multiplication and addition. So PEMDAS tells us we multiply before we add. So multiply, then we add. Okay. If an object starts at rest, just like our marbles did, or from a stop, that's on NAR, then initial velocity equals 0. Okay, let's go ahead and do our initial velocity equation. So this time, if we're looking for initial velocity, it's going to be very similar, okay, but algebra makes it just a teeny bit different. We're going to have our final velocity, Vf, minus, so now we're subtracting A and T, or A times T. So acceleration multiplied by time. So when they're next to each other, we multiply it, remember? And again, please excuse my dear Aunt Sally, multiply, get that plugged in, then we subtract Vf minus whatever we get from this multiplication. Okay, so we're going to add that if an object comes to a stop, then Vf equals 0. So if the object's moving and it comes to a stop, the final velocity is going to be 0 in that equation. So paying attention to what the story problem says. If it says a ball was rolling and comes to a stop, what's the initial velocity? And then it gives you acceleration in time. You have to remember that the final velocity is 0 if it comes to a stop. Okay, and last, we're going to do the time equation. Oops. And I could go through and show you all of the algebra to do this, but right now we're just going to give you the equations, and if you're interested, I can give you the algebra. So time equals, and it's going to look just like our acceleration equation, except for the A and the T are switched. So if you look back up, acceleration equals Vf minus Vi over T, and this is going to be time equals Vf minus Vi over A. So the algebra works out perfectly if you're interested. So that is the time equation. So we plug in all of the variables to find time. Okay? There is unfortunately no circle for this because of the fact that we have a subtraction in here and it's not just multiplying and dividing. So no circle, unfortunately. So you just got to know the equations. Okay, so let's go ahead and go through some examples. And I will move the camera so you can see what I'm doing here. Okay, so the first one we're going to do is just a basic example for acceleration. So the first one is going to be find the acceleration of an object that starts at 5 meters per second and goes to 22 meters per second in 6 seconds. So the question is asking us to find the acceleration. So we're going to circle what we need, find the acceleration of an object that starts at 5 meters per second and goes to 22 meters per second in 6 seconds. So we are going to find what we need and underline what we're given. So that gives us A, VF, VI, and T that we're looking for. And we are just going to fill out all of these variables. So if we're looking for acceleration, that's going to be our X. And remember, we're looking at our velocity units, which is meters per second. So this is going to end up as meters per second squared. Our final velocity is the ending. So it starts at 5 and goes to 22. So our final is 22 meters per second. Our initial is 5 meters per second. And our time is 6 seconds. So now we got to figure out the equation. We're going to use the acceleration equation. So A equals VF minus VI over T. And we're just going to plug these into that equation. So X meters per second squared. And remember, the squared is just the seconds. It's not any numbers. You never square the number. Equals my VF, 22 meters per second, minus my VI, 5 meters per second, divided by my time, which is 6 seconds. Here's a 6. And we are just going to do orders of operation. So remember, you have to solve everything on top of the fraction and then everything on bottom before we do our division. So to solve, we have to do 22 minus 5. And so we go 22 minus 5, or you can do it in your head and know it's 17. Carry over the units. And then we're going to carry over the 6 because there's nothing on the bottom to do. Now remember 17, and I'm going to go 17 divided by 6 equals 2.8 with 3 repeating. Remember, a meters per second is how we're going to get our acceleration unit of seconds squared. So that's going to give us, and I'll just round, 2.8 meters per second, or meters per second squared is our answer. Okay, number 2. What is the final velocity of a ball that accelerates at 25 meters per second squared over 16 seconds if it starts from a stop? Let me just extend that a little longer so I don't have to use another line. Okay, so in this case, what is the final velocity of a ball that accelerates at 25 meters per second squared over 16 seconds if it starts from a stop? That's important. We talked about that. So we're still going to need our A, VF, VI, and T, all of the variables. Acceleration is going to be what we find with the squared in here, 25 meters per second squared. Our final velocity, what we're looking for, so that's going to be X meters per second. Our initial starts from a stop, so it means it's 0, and our time is 16 seconds. Okay, so we are going to plug it into our final velocity equation. So final velocity equals initial velocity, and if you remember from the equation before, initial velocity is plus acceleration multiplied by time. So plugging it into here, I'm going to go X meters per second equals my initial velocity, which is 0, plus my acceleration, 25 meters per second squared, multiplied by my time, which is 16 seconds. And now I am ready to solve. So I need to multiply before I add. Even though that's a 0, just remember, multiply first, then we add. So I'm going to do 25 times 16, and I'm going to get 400. So that's going to be 400. And since that is a meters per second squared, okay, that's going to give me a meters per second times, or per second per second. So that's how we would write it. And I'm multiplying that by a second right here, this time second, over 1. because everything's over 1. And that means I can cancel the seconds on top and the seconds on bottom, and that leaves me in meters per second. So that means I have a meters per second. So 400 meters per second plus 0, and I know that's just going to be 400 meters per second, and that's going to be my final velocity. Very fast ball. Okay, number 3. What is, let me pull that up for you guys, the initial velocity of a car that is accelerating at 2 meters per second squared over 4 seconds if it ends at 10 meters per second. Okay, what is, circle what I want, initial velocity of a car that is accelerating at 2 meters per second squared over 4 seconds if it ends at 10 meters per second. So again, A, VF, VI, and T, same variables, doesn't matter the order I put them in. So I'm looking for my acceleration. I'm looking for that little squared in the unit, and that tells me 2 meters per second squared is my acceleration. My final velocity, it says it ends at 10 meters per second. So that's my final velocity. My initial velocity is what I'm looking for, x meters per second, and my time is 4 seconds. So now I need to find my initial velocity equation. So it's going to be VI equals VF minus A times T. And I'm going to plug them in. So x meters per second is my initial velocity equals my final velocity, which is 10 meters per second, minus my acceleration, 2 meters per second squared, multiplied by my time, which is 4 seconds. And again, I multiply 2 times 4, which is going to give me 8. And I remember from the one above how this all works, and it ends up being meters per second, which is important because you cannot subtract or add terms that are not the same. So you can't add a meters per second squared or subtract from a meters per second, okay? So it ends up as a meters per second once we multiply acceleration and time. I'm going to drop my sign down, my subtraction sign, and my number, my initial velocity, or sorry, final velocity that I haven't used. So now I am able to solve 10 meters per second minus 8 meters per second, same units, mean I can solve, and I know that 10 minus 8 is 2 meters per second. So my initial velocity equals 2 meters per second. So that's what it starts at. Okay, last one, number 4. How much time? So we're going to do a time one. Does it take a bike to accelerate? Pull this up a little bit. From 3 meters per second to 15 meters per second at an acceleration of 2 meters per second squared. Okay, how much time, circle what you need, does it take a bike to accelerate from 3 meters per second to 15 meters per second at an acceleration of 2 meters per second squared? So A, VF, VI, and T. Acceleration is going to be the one with the squared, so 2 meters per second squared. My final velocity, so it goes from 3 to 5, so my 15, sorry. My final is 15 meters per second. My initial, 3 meters per second, that's what it starts at. And the time is what we're looking for, so we're going to find that in seconds. Okay, so now we're going to plug it into our time equation. Time equals VF minus VI over A. So time is my x seconds. So x seconds equals my VF, 15 meters per second, minus my VI, which is 3 meters per second, all divided by my acceleration of 2 meters per second squared. So orders of operation, do know I always have to solve everything on top and bottom before I divide. This is not, the squared is not doing anything to the number. It's just the unit. So remember that in acceleration, never square the number. Okay, 15 minus 3, I know that is 12. And since they're like terms, I do get to use them in subtraction. And I'm going to divide that by 2 meters per second squared. And I know in my brain that 12 divided by 2 is going to give me 6. Now the question is, I know I need seconds. How did I get from a meters per second divided by a meters per second squared and get just a seconds left? So I'm going to just break it down really quick. We've got a meters per second divided by a meters per second per second. Woo, lots of stuff. So I'm going to get rid of this second on the bottom down here first. So I'm going to multiply by seconds over 1. Okay, that's going to get rid of this, and that's going to get rid of this. If I do that to the bottom, I also have to do that to the top, which gets rid of this and this. But I'm not done. I still have a meters and a seconds. So now I have a meters per second on a bottom and a meter on top. I'm going to multiply by this reciprocal, second over meters. And that's going to cancel out my meters and my seconds here. Oh, sorry, not second over meters. My bad. I'm going to do that on top. There we go. And then that's going to give me, there we go, meters canceled. Now I have nothing to cancel anymore because I canceled all these already. Okay. So this was my second over meters on top, second over meters on bottom, cancel my meters. Okay. Canceled my seconds. And now I'm just left with one of those seconds left. There's a lot going into that. I don't expect you to know all that, but that's how we got to seconds. So our time equals 6 seconds. And we're done.